Okay, let's list all the perfect squares up to 225. So the first perfect square is what? You guys want to say the 1? Okay, I'll take 1. 1 could be kind of what's the word? Controversial. Okay, what's after that? 2 times 2 is 4. And then 3 times 3 is? Okay. And then 4 times 4 is? 16. What about 5, 5? 25. 6, 6? 36. 7, 7? 49. And then we have, what's after 7? 8, 8? 64. What's after that? 81. What's 9 times 9? 10 times 10 is? 100. And then we have 11 times 11? 121. And you're like, why are we doing this? Maybe the question right after that is related to it. 12 times 12? 144. 13 times 13? 169. And then we have 14 times 14. Oh, I think it's 196. Can someone type it on the calculator? Let's double check. So was it 16 times 16? Oh. No, 14. Oh, silly me. 14 times 14? 196. Yay. What about 15 times 15? 225. And it says up to 225, so I can stop right there. Questions on that? Okay. All right, the next piece. I like these two questions. Some people think they look identical. It must be basically the same answer. That's not the case. All right, let's start by simplifying the radical for my number 8. Because I have a 5, I think I want to do 5 times something. 5 times how many? 525 divided by 5 gives us 105. Are we okay with that? Can we do 5 again? Okay. Divided by 5 again, that's going to give us, I see 21. Do you? For 21, let's kind of talk about real quick. If I split 21, isn't that 3 and 7? Yeah. Can I get anything identical on that? So I don't want to go on further, but I do have a pair of what? 5. So we have 5 radical 21. And a way to check this would be, you type in your original equation on your calc, and you type in your final answer, and it should be the same ugly decimal answer. Do we all see that? Okay? All right, the next one. The first thing that we have to do, we need to go ahead and add these two first, yes? It says to add in the inside, so I have the square root. That's my overall operation. So if I take 36 plus 49, 80 how many? 85. Looks like 5s are the winners here. So let's take 85 divided by 5. What do y'all get? 17. Isn't 17 a prime number? So is there any pair I could take out here? So that means square root of 85 is as far as I can get. Now let's do the other one. On the other one, there's a radical independently, correct? So what is square root of 36? 6, all right, plus square root of 49? 7. And 6 plus 7 is how many? 13. So does that mean these two numbers are identical? They're not, okay? So don't be making up math thinking, well, I have a square root separated versus not separated. They're two different problems. So let's go ahead and box that. Okay, Ken, go ahead and read number 9.
The length of a rectangle is 3 centimeters more than the width. The area is 70 centimeters squared. Find the dimensions of the rectangle.
Okay, so we have a length of the rectangle. So I'm going to call, doesn't matter which one the length and the width is, because really in the end we have 2 length and 2 width. So 3 more than the width. So we have 3 more than means plus 3 at the end and x. Okay, any questions on that? Good? And it says the area is 70. So to find the area, am I multiplying the length and the width or adding the length and the width? We are multiplying. So I'm going to say x times x plus 3 is equal to 70. What does your gut tell you to do next? I think I heard it. Distribute. So we have x squared plus 3x is equal to 70. And to kind of think about what we did back in Algebra 1, when factoring, they were always set equal to what number? 0. So I need to move the 70 over. So x squared plus 3x minus 70 is equal to 0. And then let's make our little x. We did factoring last week. Not for no reason, right? So I need to figure out what can I multiply to get to negative 70, but combine to get 3. Give me two numbers. 10 and negative 7. Very good. Because when I multiply these two, I get negative 70. When I combine, I get 3. And because my coefficient is 1 in front, I can do one go. X plus 10, x minus 7 is equal to 0. And it's asking us for the dimensions. So let's kind of recall from Algebra 1. Didn't we set this equal to 0? So when I said x plus 10 is equal to 0, x becomes what? Negative 10. If I set x minus 7 equal to 0, what do I get? X equals 7. Can you have a negative dimension? No. So that means negative 10 will be an extraneous solution. So that means we have 7 is my dimension for here. And for the other guy, when I add 7 plus 3, how many is it? 10. So it'll be centimeters and centimeters. And if you have a trick on the calculator, you may use it. All right. Jack, go ahead and read the instruction above number 10 and number 10, please.
I have a counterexample that could demonstrate that the statement is false. All supplementary angles are linear pairs.
So every supplementary angle are linear pairs. Is that true? So let's kind of think about the definition. Supplement means I can add any two angles equal to how many? 180. But linear pair is very specific. Not only is it 180, but it has to be adjacent. Very good. So in this case, I could say my counterexample will be if I make an angle 30 right here, and somewhere else up in the air, I make 150. We know that is supplement, but is it a linear pair? No, so it's false. So my counterexample is my example that I just wrote on there. So 30 plus 150 is 180, but they're not next to each other. Everyone good with that? Okay. The next one, let's see. Morgan, go ahead and read number 11. Okay, if two angles share a vertex, does that guarantee they're always going to be next to each other? So let's draw one then. So here's my vertex. And I'm going to say I'm talking about angle A over here. And then I could go over here and make another angle and say this is my angle B. Those two are sharing the common vertex, correct? But are they also adjacent? No, there's a gap. There's a gap right here. Okay, so this is, again, false. And if you want to write that verbally, that's up to you. I like the visuals better. We're good?